Hello, good afternoon. It's still me, just without glasses. I have contact lenses today. We do Codechef lunchtime. Do I need to register? Directed 3. Still they don't do drawings. Or subtasks with small n. Do you want drawings? I can make drawings. It's not that I care that much about Codechef rating. Tools, pen size, this, okay. One, two, 3, 2. I will later grab a drawing tablet. And in the other 1, 2, 3. I don't really see anything here. What happened? 1, 2, 3. Maybe I need to think about choosing a subset of existing edges, so that they would all be directed from something out. No, that's not really it. Is this by difficulty? Don't know. Root the tree. Okay, this is the easiest problem. I was 2 minutes late, but not a big deal. From 3 to 1. Let's think. There is never a cycle. Is this condition enough? To every vertex, there should be at most one edge going in. Yes, I think this is true. So sum over in degree and something. Input degree of this vertex -1. Accepted, I think. Does that mean 100 points? Infinite grid. The length of my output is up to this. That's like R times C. That's 400. I can have R squared times C if I want. If it's just a row, I can keep going to the right, like 100 times, and I will stop somewhere. So maybe something like go to the right, then up by one cell, go to the left, if I move right left, then normally I will stay in the same cell, but if there's obstacle, then something different happens. What's up with the refreshing? Would be nice to just make this pattern. I think I know. I will get here just to the end. So I will get to a cell. As an extra, I will make W moves. W more moves in every next cell. This will be W cubic in total. Around that. Should be good enough. Would have thought that this problem seems like a Codeforces problem a little bit, because we have a Codeforces coordinator as the problem author. Left columns. I start in 0, 0. Up. If direction, then to the left, otherwise to the right. Wait. I don't think that's correct. Should be W. I think I need this. I will go here by extra 0, here by extra W plus 1, then here I want W and 2W, 2W and 3W, and so on. Okay. In total by 1, by 3, by 5. It's a bit scary to submit this. Are there any rules? No penalties for incorrect submissions. Who achieved the score first? Cool. Accepted, we move on. If I knew that there is no penalty for wrong submissions, I would just try here like 2 different values without making drawings. 13 minutes into the contest, 3 problems left. Up to 100, so it might be dp of n and the number of inversions. Only print yes or no. For this, the answer is no. Is it because of the parity? Right now there are 3 inversions, and after a split it will be 1 and 2. No, 1 and 0. I won't be surprised if we don't really understand what is the split into 2 sequences. But if there is one inversion in the input, we can split into two permutations, two subsequences, so that there would be 0 and 0. So it's not just about parity of inversions in the input. Might help to implement a brute force and check for what sequences it's possible. Why won't I now submit this? Just to make sure the brute force is fine. But my real goal is to print, I think, sequences for which it's impossible. And I think that for random sequences it is always possible. Something's wrong. Nope. Partially correct answer. Cool. Now, let's say that I read this once. Okay, one more thing. I want to also print the number of inversions. the number of inversions is 3, or it's quite big. 6 at the end does nothing. This will be set of possible differences. It's not about parity. If it isn't about parity, then I think I'm going in the wrong direction. Let's try to think about the P. Or maybe it matters, the parity of n matters a little bit. (11). After processing some prefix, for the next number, let's say that we have 5 here. I know the number of smaller numbers on the left, and I will have a choice. Let's say that this number is 10, and there are 3 smaller numbers on the left. Then I will have a choice between x and 3 minus x. Where x is the number of those bigger numbers in one of the two subsequences. In terms of differences, I want at the end the number of inversions in one sequence minus the other to be 0. So if this will be x or 3 minus x, then what I'm adding to the difference is x minus 3 minus x, so 2x minus 3. And I want the sum of such values to be 0 at the end. I know x's. No. I know those. So I need some particular sum of number of bigger elements than you in one sequence. When I switch this number from one type to the other, then how will x change? Wait. No, I'm saying something stupid, right? Because I have a choice between this and that. This would go to the first sequence, this to the other. Okay, but still. What happens when I change this from yellow to red, so to the other sequence? I need to subtract all small yellow numbers on the right, all big numbers on the left, and I need to add those red on the right. This was supposed to be minus. Big red on the left. Still nobody. It's a bit easier when we switch the last element. I will think about another problem. At most n over 2 plus 1 distinct elements. Continuous, so all intervals should be good. There cannot be too many distinct elements. Among 3 elements in a row, 2 of them must be equal. Among 5, 3 must be equal. But if it's satisfied for sequences of length 3, I think that it's just about satisfying this for intervals of length 3. And then everything will be guaranteed. Among each 3 consecutive elements, they must contain at least 2 equal numbers. That's it. Okay, then what do I do with that? If I already decided about those, initially those were three distinct numbers, A, B, C. Is it true that now two of them are equal to each other? Maybe they're equal to some another value, x. Do I need to remember that it is some x and it also appears there? If there are three good numbers, like A, B, A, can I say that I get now to... Okay, if it's like this, if there is AA in a row, two equal numbers, then I think I can split the sequence into this and that. Maybe when processing this part, I will try to make this number equal to element to this one. Can it happen? And can I avoid it? And that's only necessary if those are different, x and y. But then here, this one was x or y. If it's y, no matter what, a can be changed as well to y, or y can be changed to x. Yeah, if this is the situation, then y can be changed to x. It doesn't hurt, instead of changing me. So indeed, if two in a row are equal, split the sequence. Now what about this? Or just generally sum two equal numbers? Because it seems to me that if everything is different, A, B, C, D, I will change this to A, and so on, every second number. Maybe some numbers are equal. If this is the case, then maybe it's better to change those to B's. Let's say that this doesn't exist. If this here, I can maybe make quadratic DP. There are only n different values in the input, then I can have DP of position and what value happened. Is it true that among three elements I change only one of them? Changing two seems stupid. Oh yes, of course. I need to. Because if everything is distinct, if I change this to something, I cannot satisfy both this and that by that. If those are four distinct elements, I need to also change U. But this is not enough. This must be satisfied. So if everything is distinct, oh, there must be two equal in a row, or something like this, A, B, A, B. Because if this is not B, that's bad. If the last three elements were A, B, A, this must be B or A. If it's not, then I need to change it to one of them. Change this to B, change this to A, and then eventually this is A. Then I start from here. Another quadratic DP will be to consider some interval of elements such that it must be xy, xy, xy. On even positions and in odd positions, find the most frequent number, and that's it. Those will be AB, AB. Or maybe not, because I want to make this a... Some people solved split. The problems today are quite difficult. And that's good. The last one will be an integers in a circle. You can take 3 consecutive elements and add 2 to them, or subtract 2. And this must have a polynomial solution. I think that this is easier. In this situation, when we have characters B, for sure B will be the most frequent character among those positions. Otherwise, it would be better to change it to something else. What about A's? It's possible that A doesn't appear in any of those positions initially. It's just that I want A here. But then could I replace A with this C? Also, this is possible, right? No, I mean this. Now B is here. Then there is, let's say, E. When I move forward by 1, I only need to remember those two values. So it will be dp of I and then value 1 and value 2. I, x, y. Possibly x is equal to y. Then transitions are constant time if x is different than y, because the next number must be x or y. And that's cubic dp. So good enough for this subtask. In a moment I will just implement this DP to make sure that my solution so far is correct. It will take 3 minutes or so. There is no time penalty for that, other than my time. And if x is equal to y, then the next number can be anything. I wonder if there is AA and then the next number is A. Can it happen that I want to modify that next number to something else? Highly doubt it. What about this? If there is AAC, can it happen that I want to change C to something else? Well, this will be to fix this or that. If, oh, if this is not equal to B already, then I can change it to A. Same here. This will simplify so much. Okay. Final. This either was B from the very beginning, or if it wasn't, I'm changing this to A. Now, when I'm after this situation, actually, is it the same here? Yes, it's either A from the very beginning, or I could as well change this to the same character. So maybe I can remove this. Those will be BAB. If there is BAB, then I know that A was there from the very beginning. Let's say that this is like strong A. If there is A here, it means that this was there from the very beginning. If there is B here, this was there from the very beginning. Now, how can this change? B, C, B, then already this was there from the very beginning. Now those two, they could be as well A and C. I mean, this could be A, this could be C. Can I change them both to A? No, because I will mess up this. But I can change this to C. A and C is not worse. So always a number will be equal to it will be a block of equal values. So either get the previous number or use the next one. Okay, two consecutive values are the same. I can move with blocks of at least two consecutive values, or I can say that two last values are just like they were at the beginning. let's think. If there is a long sequence like that, if this is the case, then this makes sense if both B were there initially. If at the beginning we didn't have them, this was something else, then it's easier to change this into A. But yes, it is allowed that with distance free from each other, there will be these different characters, non-A's. And those is just something we don't change. But if there are at least two, we are fine with at least two A's in a row. If one of them, so let's say uppercase will mean it's there from the very beginning. Can I change this to all B's? Can't. This can change into B's, for example. What else can happen? B. This makes sense only if this is B from the very beginning. Now, if you want to leave this as B, then this can be B unless this was A from the very beginning. But then I would just say that this is not really. So we can start a new sequence, I mean a block with new value, and we could continue here with A, with just A. So apparently this was B, because otherwise I would move on with A's. When there is some new character, we can switch to always using this character. Except for every third position. And there is also this A here. If it's this, shouldn't I change those to E's or B's? Can this be E? Then that is messed up. But can I change both to E's? Yes, unless well, this is A or this is A already. Uppercase means it was like that from the very beginning. But in this case, I could. Oh, there's also this case, obviously. I think here I could change this to E. And that's better. Just treat this as a sequence of a block of E's. So if A is here, that's possible. If A is here, we could as well change this to E. So a single different character is possible only if the next character to follow is A. If I have a block of A's, then A allows non-A to be a moment ago. Then this is like whatever. I don't care. I don't change it. And I don't change U as well. So if there is a long, right? Here, if it was X, it's not true just before that. Well, we could change this into B's and this into C's. We could. Just let's say that before a character we can already start a block with this character. Unless if this is A, this is A, then we already said that, yeah, this is possible. So then A must follow. What about that? Generally, if there is this, then I will change all of those into B's. What might be an issue? If this is the input, I will change all of those into B's, and this will be C. Okay. Now what if this is A? Then those will be A's. Up to this moment, B's. What if this is A? Well, then just we start a sequence of A's. So it's enough to consider my surrounding. I think that's the main thing. Because if I claim that for a long time I change things to A's, and A is not there, then well, this is some character. And I can change it to this, exactly this character, and what follows also I change to this character. So I claim that if initially we have this, on this position at the final sequence I will have one of B, C, D, E. And this will be n times, well, some complexity. No, what's the time limit? 1 second, not very fast. They should remove this a few different elements. I should have guessed something like that. It took me too much time to understand the whole process, and that was unnecessary. Okay, whatever gives you accepted. Let's see. One person solved it. At least you will see that I didn't really guess the property, I really understood it by analyzing what might happen for a long time. Moving forward, I need to remember two last elements. I guess there will be only like 5 possible states of what might happen, but I will have more. Did I use a map? Yes, I will use a map. Let's say that -1s, they can be anything. Is that fine? This is the number of moves at the end. For every I. Iterate over things already in DP. Iterate over new number, let's say new x in possible values. Then check if this is fine. So if a is equal -1 or a equal b or a equals c or b equals c, then it's possible, and we need to say that new dp of bc is minimum of itself, comma, this is state dot first dot second, and state dot second will give you the actual dp value, plus we add 1 if c is different than the current ai, if we make a move. Here this is more complicated because we need to say new dp dot count of bc, then this what's wrong? A is the array. That's surprisingly easy code. Should I try a huge random sequence? No, because there is no penalty for wrong submissions. No. I might get time limit exceeded, but then at least I will pass already some tests and I will know if the solution is correct. If I get wrong answer, I will increase this. This checks how big surrounding I check for values this. Like if I'm on position I, now I claim that at the in the final sequence there can be only values from initial sequence from positions I minus 2 through I plus 1. Time limit exceeded. Can make this a little bit faster. What about doing, say, initially 1? Everything will be greater by 1. Minus 1. I think that this works as well. And might be even twice faster. I want to leave this page open in order to see the times, how much it improved. What else can I change? I can, instead of a map, some vector, then sort, like merge consecutive equal. Then there is no need for map at all. And I think if I get time limit exceeded, I need to do that. It should be done. Oh, correct answer. Barely. I improved it by something like 5–10%. I'm happy that this was enough. Soon already solved a superset of my solved problems. Few people solved the permutation split. Split a sequence into 2 with the same number of inversions. What can I do? I can do the P. I can do some randomized solution that will keep improving, keep going towards the score, but maybe there are some sequences where really we should do something very special. And the longer the sequence is, the more chaotic small local changes are. If there is some sequence for which there is only one solution, only one way to split, then I doubt I will find it with any randomized solution. Anything, you know, like climbing up the hill, maybe, or annealing, simulated annealing. If I flip the whole suffix, for each of them change if it's inside the sequence, inside the first sequence or not. If there is number 6 at the end, . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . If the sequence has length 7 and there is number 6 at the end, then I can add 1 to the score. Or I can do 0. If there is number 5 at the end, maybe I don't have a choice because it's +1 or +1. Or maybe I can add 2. Almost 2 hours left. I would be happy to finish earlier though, because there are a lot of contests this week, including some Open Cup, ICPC training, and it means I will spend more than 10 hours this weekend, like Saturday and Sunday, during contests. And while it's fun to take part in competitions, it's also fun to do other things in your life. This code is correct because I submitted and got 20 points. I really hoped to see something from the outputs. Maybe some DP. Can this be like a knapsack? If a number has a lot of inversions with other numbers, like some element has a lot of inversions with other elements, so it is like a small number at the end. And if the split is random-ish, then this number will affect the score a lot. There are sequences like this: 2, 3, 4, 5, 6, 7, 9, and 1. The only solution here is to put 1 in the other sequence. If it's 1 and 3.5, let's say, just shift everything, then the answer is impossible. What about this? If the sequence is almost sorted, and it means only at most like square root of n elements are off, then the answer is yes. I don't need count inversions because it's the last element of something I'm printing anyway. This is almost sorted, so like number 1 and 2, they don't really produce anything. Maybe I will try to find a long decreasing subsequence. What's really the state of dp? The position, the difference between the number of inversions, difference of the number of inversions, and the state is actually, like, if here I process this prefix of values 8765, then I care how many of them are taken to the first sequence. If there are different blocks, like here I processed those values 87634, then I want to know how many of 876 and how many of 34 were taken to the first sequence. And maybe if there are a lot of blocks, if there are a lot of blocks, then the answer is yes, it's possible. One at the beginning doesn't matter. Trying random subsequences will not be enough. Or will it? I can easily see how many times I need to repeat to solve subtask 1 to get accepted there. Where is my submission? Try 100 times. Try 1,000 times. Hundred was not enough. If 1,000 is not enough either, then there's nothing I can do. In nlogn I can account inversions. So 1,000, already 1,000 times to generate a random split and check it, it's too much. Gennady also didn't solve the first problem yet. I see that he waited a little bit with his submissions. I'm not doing terribly. Why is n small, if not for dynamic programming? Maybe it's about this claim with a lot of different blocks. If was of x is not was of x plus 1, we have a new block. Need to do it in a different way. Grab the iteration over all permutations. Just find the maximum count. If we return false, just print this. For this, it's impossible, even though the permutation seems quite random. Another wrong idea. I wanted to check that maybe often it's possible to get difference 0 or difference 1. No, that's not true. Hmm. Can it be anything different than dp? I can go from left to right, or I can go through sorted values. Mm. 8 people solved it. This must be an easy problem. But maybe I will have a fresh mind when approaching it again in 1 hour. Now let's try this. At least a subtask. Because only subtask is solvable so far. Adding to interval corresponds to, if we look at differences of every 2 consecutive elements, this means we add b somewhere and subtract it x positions later. The subtask is basically that we start with a sequence of zeros, we want to end with sequence of zeros, but every value should be different. This might be some kind of flow. I can increase number and subtract number 2 elements later in the sequence of differences. Let's model it by drawing a directed edge with cost 2, value 2. I can in particular add something to everything by doing this. +2, +2, plus 2. Let's say that I also keep track of the sum of all numbers, and I want to change this sum from something to 0. And applying this edge once increases the sum as plus equal twice the cost. 2 is actually the length here, so maybe I will change this. Here is not important. It is possible to change all a's into all bigger a's, so also all smaller a's, and it seems to be like kind of like GCD. What's the smallest I can do? Might be related to flows. Values AI aren't huge, but AI times n will be already too much. I'm tired today. That's bad, because in the evening I have a 1v1 against Steven. Short lockout match. Okay, so is this about just GCD of all b's? I will check that. A must be divisible by GCD of all non-zero b's. That's my idea. If I get wrong answer, then what? I don't have any overflows. I can test a little bit to understand if I made an if for already zeros correctly, for example. That was easy to miss. If GCD of values b, wait, I need to check something else. No, not really. Here it's no. Here it's yes. No. Question marks. If this is divisible by GCD, then I can indeed do things. Well, maybe n matters as well. If n is equal to 5 and something has length equal to 2, then I need to apply this thing five times. No, twice to every position. So it is not really correct for like length 5. This is no, and if I just do this, it shouldn't be yes. Maybe I should think more about the sum of numbers. So I can now increase the sum by 2. What? Not times I plus 1. Times I plus 1, yes. I want to get 4. I'm quite sure that this will not work. Because I can add to length 2 and length 3. Subtask 1. One test passed. Don't know if that's a good sign or not. So this G2 is about how much the sum of all numbers changes. I don't know if it's equivalent, but I can investigate if I use this number to increase every number in the sequence by the same value. What kind of flow is this? What do I want? Can I say that this cost is by how much I increase the sum of all values? So exactly this. This will be cost of an edge. If I'm given AI, then I can iterate over divisors of AI. And I can say that I'm trying to achieve exactly that much. Let's just assume that AI is equal to 1. All values A are equal to 1. What then? I need to use such values b that their GCD is 1. I still think this is a flaw, but I don't know how to model it as one. How to force that something is happening here, but as little as possible. Is this just like max flow in a network without source and sink? I never used that. But what, some costs will be negative and I want to be very close to 0? Six people got 40 points here, 10 people got 100 points here, and if I solve this I will get plus 40, if I solve this I get plus 80. And let's get back to thinking about permutation split. So aiming for the score of, well, 400. Because we can already see that this is not easy for 100 points. If I want to get good rank, I need to get 400 at least. But likely I will not get more. Split sequence into 2 subsequences. If there are no inversions, then whatever I do, it works. If there is one number off, and the other numbers don't have inversions between them, then this one number can go out to the other sequence, the second subsequence. Otherwise, well, things are complicated. dpf position and the number of inversions. What else? Meet in the middle. Nope. Divide and conquer. Neither. One hour left till the end of the competition. Maybe this is too sad. Like we have, when we have an inversion, then if both are in the second sequence, we get +1. If both are in the first sequence, we get -1. We want the sum 0. If this was absolving, I would already now for sure look at the editorial to get some hint. But well, it's not absolving. I wouldn't be surprised if somebody already has known this problem. The statement is quite simple. Maybe we look at a few consecutive values and we say that they must belong to the same sequence. Then we can do dp in 2 at power the number of blocks. Or for every difference in the number of inversions, keep some solution and then try to change it a little bit, like flip one number or swap two numbers in order to get a new number of inversions. If I start with a random split, the difference in inversions will be around -n to n. It will not be far away from 0. It's not that I will get n squared. And I think that maybe it's enough to investigate those splits where the number of inversions indeed is similar. Can this work? I don't think that it would be possible to prove that this is correct, so this is not the intended solution. But I see some strong people behind me who are in the similar situation. But the people solved this. I will try the solution with for every difference in the number of inversions. I will try to find any solution, any such split, and just consider flipping every number, and then you might get new difference between number of inversions. Random split. If this do that. This will be a queue. A queue and place back need div comma starting sequence, possible div. I'm saying that this will work with like 10% probability. I smaller done. Consider flipping. So type of I will become not type of I. And I need to know what will change after that. If it's an inversion and they are of the same type, then this. Type of I. If not, okay. It's incorrect for the third sample. That's very bad. Nope, nope, nope. First of all, does it pass the first subtask? I can also repeat this several times. And if it passes the first subtask, what I will do is I will forbid differences far away from 0. What is this? I didn't submit? Did I submit? And then if it's bad if running this on sample test gives time limit exceeded. Maybe for big N there is bigger probability that this will work. So maybe even if I get wrong answer on this, it makes sense to say if N small then brute force, if N big then try this 5 times. Do I use map? I don't. Why so long? Really? You know, I don't know, getting good results. It isn't anything that getting good results is a mix of skill and luck. What now? I will get now 7th place. And getting those plus 40, I might getting it quickly will give me 4th place, so it's anyway not top 3. Then I don't care. I think it's some kind of flow. I don't like graphs, I don't like flows. I will think for a moment. Yeah, 7th, possible 4th. So I will just think for a moment about some additional ifs. No. But I will need to say that it's possible to modify several parts. I'm assuming that all a's are equal to 1, because that's easier. What is difficult here? It's difficult if, let's say, n is equal 9, and with len 5, I say +1, and then with len 2, I do +1. But it seems to be now like a knapsack on sums of numbers. And I tried to hack that with caring about the sum of elements and single elements. Am I correct here? If this is bi, if non-zero, compute GCD. GCD of values and GCD of sums of values. Maybe this is stupid. If I add +2 here and +3 here, my program will think that this is already good enough. I can, like that, increase everything by 6. If I just use this, I will increase by 27. If I just use this, I will always increase by a multiple of 3. Is that correct? Do single values matter at all? Maybe I should only care about G2. But then, if I can change the first element by +5 and n is equal 5, this will incorrectly think that things are possible. I can use a subset of numbers such that their lengths, possibly with multipliers, they sum up to n, and then I increase everything but by their LCM. So I want each of those to be divisible by AI. But if something is not divisible by AI, is it useless? Maybe it is solvable with a series of ifs. But it's for sure not fun for me. And yeah, I need to do some other things before my match with Steven. So I will call it a day here. If it was like eliminations for some on-site competition, then I would fight for the very end. Right now I'm fighting to advance from 7th to 5th place, so whatever. And there is 26 minutes left, but I already hesitated to participate because I don't have enough time. Thank you everybody for watching. I'll myself curious later to see the editorial for the second last problem, so permutation split. I don't know if that was intended or I just hacked it and they didn't predict something like that. I know how to make it faster by only allowing differences closer to 0. I had a few ideas in mind how to improve it a little bit. So wait, this is split? No, split 2. I also wanted to run this several times, every time with a different starting sequence. Because I believe there are sequences for which it's difficult to get the solution. And my solution is not, I cannot prove that it's correct, because for every difference between the number of inversions, it holds only one such split. But there might be 1,000, and maybe only from one of them it's possible with a flip to get to the solution. But well, I won't complain. So I will read later a tutorial for permutation split and for the problem I couldn't solve, add-on segment. Maybe a subtask is solvable with simple number theory, like greatest common divisor and LCM. But I bet that the full problem is just flow, because it looks so. Maybe I'm wrong. That's fine. Thank you everybody for watching. Check link in the description for final standings and the editorials. They will publish it somewhere here, or maybe when you open a problem and you scroll to the when you scroll to the bottom. I don't want that. This is a very strange behavior. So when you hit this short code, it lets you submit. This is statement. Not intuitive. Usually they usually publish editorials here. And that's it. Thank you. Bye bye. Have a nice day.